Lesson 2.1, composition of functions. So we have 4 objectives in today's lesson. Evaluate the composite at a given value of x. Find the composition of one function with another. Find the composition of functions from graphs and tables. And use combinations and composition of functions to model and solve real-life problems. So let's look at the definition of composition of two functions. The composition of the function f with the function g is written as open parentheses f, there's an open circle, g, close parentheses x, equals f of g of x. So what I want you to realize is that these two expressions on either side of the equal sign, they mean the same thing. They just have two different notations. Now, when it comes to reading this right here, you can read it as f in composition of g of x. So I'm going to show you how to write that out over here. So we're going to put a little open quotes here. F in composition of g of x. Okay? But what most students do is that they end up writing, when they see something written like this, they automatically write it in that format because it's easier for them to read and understand. So if that's your preference, feel free to do that. Okay? So here we go. We're going to start here in example number 1. So you're going to see you are given two functions. One is f of x equals x plus 2, and the other function is g of x equals 4 minus x squared. So we are going to compose f of g of x. So I am going to rewrite this notation in A as f of g of x. All right, so f is composed in g. Once you have rewritten that format, what I need you to do is make sure you focus on what's inside of your parentheses. The g of x is what you are going to start with substituting. So I'm going to put an equal sign. I'm going to bring down the f because I've done nothing with my f, and I'm going to substitute g of x with what g of x actually is. And if I look upstairs, g of x was given to me, and it's 4 minus x squared. So I'm going to replace that highlighted g of x with the expression 4 minus x squared. Now what am I going to do? Well, what I'm going to do now is I still focus on the inside of my parentheses, which is 4 minus x squared. And what I'm going to do is I'm going to take that quantity and I need to substitute 4 minus x squared into my f function. All right? So if I look upstairs at my f function, I'm going to notice that there's only one place I can substitute 4 minus x squared, and that is in the x. Okay, so I'm replacing every variable in f. So I look at my f function. The x, which is pink, is going to be replaced with 4 minus x squared, and then I need to bring down the positive 2. Okay, so what I want you to notice is this right here used to be an x, right? The pink x, that's what it was. That used to be x plus 2. But I got rid of the x and replaced it with 4 minus x squared. And once I have replaced it, combine like terms. Well, 4 plus 2 is a 6 minus x squared. And then I stop right there, okay? Remember, when you are talking about the concept of substitution, think of it in reference or in analogous to a teacher being substituted. When, for instance, if I were to leave the classroom, a substitute teacher comes in and replaces me. Now, the substitute doesn't look like me, but will take upon my responsibilities, okay? So the substitute is in place of me. So when I took this pink quantity of 4 minus x squared, I replaced the x. in the same position. So it's still going to add to 2. It's going to look different, but it still needs to add to the number 2. And that is it. That's all you need to do with that problem, because 6 minus x squared cannot be simplified any further. So we stop right there. Okay. All right. Let's do the next one. Let's work this one in green here. So g in composition of f of x is the same thing as saying g of f of x. Okay. Now, just like I said before, we start from the inside and work our way out. So we are going to substitute the f of x. So let's do that. Equals, I bring down the g because I haven't done anything to it yet, and the f of x is x plus 2. So x plus 2, close parentheses. So what am I doing now? I'm going to take, let's pick another color here. Let's pick a green, no, not green, blue. Okay, I'm going to take this x plus 2, and that was probably not the right color to choose. So anyway, I hope you can see that x plus 2, and I am going to replace every single x and g with x plus 2. So I'm going to erase up here the original markings that I had. So I'm looking at the g function now, and I'm going to go replace every x with the g. So that x right there needs to be replaced with the new stuff, x plus 2. Remember, think substitute, teacher. So I'm looking at that g function. I see a 4, so I'm going to write 4 minus, I see an x squared. Now I'm going to put parentheses and substitute x plus 2 for my x, and then this is going to be squared. Okay, so that's my 4 minus x squared. Remember, this right here used to be an x, and it got replaced with x plus 2. And I am done. Okay, now you can stop there, but if you need to simplify further, I'm not sure if Delta Math requires it, I need you to make sure you do the following, okay? So 4 minus x plus 2 squared means x plus 2 times x plus 2, okay? So we're going to go ahead and simplify this first. So let's multiply using, what many students like to call FOIL, x times x, which is actually distribution, okay? That's x squared. Then we're going to do x times positive 2. That's going to be positive 2x. And then I'm going to do 2 times x. That's also going to be positive 2x. And then I'm going to do 2 times 2, which is going to be positive 4. Okay, and if I combine those, the x squared comes down, the positive 4x, 2x plus 2x, and a positive 4. So, see if I have enough space here. I'm going to keep with my equal sign. I have 4 minus the answer I just got, x squared plus 4x plus 4. And I have to make sure that I distribute this negative to every single term. Don't forget to always distribute. So 4 minus x squared minus 4x minus 4. 4 minus 4 becomes a 0. So I'm going to cross these out so you know that those became 0. And so my final answer is merely negative x squared minus 4x. So you can either, just to make sure you heard me when I say this, your final answer could have been this one right here, 4 minus the x plus 2 all squared. Or if you were asked to simplify, it could be, whoops, let me try that again. Let me raise this up. It could be minus x squared minus 4x. So either one of those works fine, just depending on the directions, okay? I might be giving you a lot of information, but I do want to remind you here, when you are expanding a binomial. For instance, x plus 2 times x plus 2, or x minus 5 times x minus 5. There's actually a shortcut. And so I wanted to just show you this shortcut so you don't have to do all of this work if you remember the shortcut. So all you have to do is square this term first, okay? And x squared is just going to be x squared. X to the second power just becomes x squared. And then what I need you to do is that you are going to multiply this, and then multiply the answer you get from that by a 2, and always multiply by 2. So x times 2 is 2x, and then 2x times 2 gives you a positive 4x. So I'm going to put plus 4x. And then, last but not least, what you do is you look at this second term, and you square it, and you get 2 times 2 is a 4. And you'll notice that this here is the same answer that you got right over here, okay? And that's all you do. That's all you have. So you don't have to write it as x plus 2 times x plus 2 and do the FOIL. It saves you time, okay? So very quick example over here. I'm going to do a really quick one. If I asked you to do x minus 3 all squared, square the first term. So square this first term, and that's going to give you x squared. Then I need you to multiply this term times this term. Well, x times negative 3 is negative 3x, but then I have to multiply it by a 2. So negative 3x times 2 is negative 6x. Okay, not sure what this was over here, what happened here. So let's go back and write that out. X squared, negative 6x. And then you're going to take this number right here and square it. And negative 3 all squared is negative 3 times negative 3 is a positive 9. And so plus 9. And then there's your answer. You're done. That's how you multiply binomials. Okay, so if you have two terms, a minus b or a plus b being squared, that are adding and subtracting, you can use that little trick, that shorthand trick. Okay, g of x. What does that mean? What does that look like? So you're going to take a g and you substitute g of x. So again, we're going to focus on the inside and replace g of x. So g of x is 4 minus x squared. So g, open parentheses, 4 minus x squared. Okay, now what does that mean now? So now I need to look at the 4 minus x squared and go ahead and replace that green 4 minus x squared for every x in g. So I need to go look at the g function, and wherever I see an x, I need to replace it with 4 minus x squared. So that what I just highlighted is what I need to replace. So 4 minus, open parentheses, my x is 4 minus x to the second power, close parentheses, and then I have to square it again. Okay, so we will, for time, we'll stop right here and assume that we did not need to simplify it any further. Okay, so there's your final answer. Now, let's move on to the next page. So that's substitution of functions. So that would be, let's see, going back here, you are evaluating the composite function with another function. So bullet point number 2. Let's go to example number 2. So bullet point number 1 says you can also do composition when given the value of an x. And in this case, that's what they gave us. So upstairs here, they gave us the instructions to find f of g of 2, okay? So what is f in composition of g of 2 mean? Well, that just means f of g of 2. Okay, now remember what I told you. We always start by working from the inside out. So we work with evaluating g of 2 first. So g of 2 means go find out what g is going to be when you substitute 2 for every x. So g of 2 is going to be, g of 2 is going to be 2 all squared, which in this case is just a 4. All right. So if I'm looking to find f of g of 2, that means now I can find f of, what is the g of 2? Well, it turns out g of 2 is a 4, so I'm going to put the 4, which is my answer that I got for g of 2. All right, because remember, I'm looking to find f of g of 2. And then I'm going here to f of 4 because I'm replacing g of 2 with 4. F of 4 just means take the 4 and put it in my f function. Take the 4 and put it in my f function. Well, my f function says the radical square root, replace the x with a 4 plus 4, and that gives me the square root of 8. Now, the square root of 8, if you guys remember from geometry, that is 4 times 2. That's 2 times 2. So if I'm simplifying square root of 8, that is a 2 times a 2 times a 2. But I take out my pairs, right? And so that's going to end up being 2 square root of 2, because this pair makes a square root of 4, and square root of 4 is a 2, and that goes out to the front of our radical, and only that pair of that 1 2 stays inside. So the answer to part A is a value of 2 square root of 2. Let's try it again. So we are looking to evaluate f of g of 2. So we need to find g of 2 first. Okay, so g, let me raise this up a little bit, all these pop-up boxes. G of 2 for this particular, oh great, hold on a second, it's changing my g into an arrow. G of 2 is the square root of 2. So now I need to do f of the answer I got, square root of 2, which means I'm going to substitute square root of 2 into my x over here. So open parentheses, square root of 2 squared, because it's x squared, plus 1. But the square root squared just simplifies to a 2 plus 1, which makes a 3. So the answer to this problem is the value of 3. Okay? So why don't you pause the video and try and do part C and D on your own, and then come back. Okay. So let's keep going and see if this matches what you did. So we're still finding g of 2. So we're replacing that with a 2. So 2 plus 6 gives me an 8. So that's my y value. When I substituted a 2, I got an 8 for my y value. That's my answer. But now my 8 becomes an x value again, because I'm looking to find f of g of 2, which is f of 8. F of 8 is going to be the absolute value of 8, which is just 8. And you're done. So whatever answer you get, you substitute it into the other function. Let's do this again. So g of 2 is 2 plus 3, and you got a 5. So I'm going to take that answer, go to the other function, and substitute the 5. So 5 goes into the f, and it looks like 1 over 5. 1 over x is replaced with 1 over 5. And you're done. Okay. All right. So that's how you do it with numbers. Let's see how it looks with tables, okay? So we're going to do part A. Now, part A says that you are going to do f composition in composition of g of 1. So let's rewrite that, okay? So f of g of 1. Okay, f of g of 1. So the first thing I need to do is go find g of 1, okay? So remember, this here, I'm going to write it in red. This number is your x, okay? That's your x. That's where you go. So I look at my x column. Here's my x column right here, all right? And I need to go to x equals 1. So x equals 1 is right here, all right? Now, from here, it says go to your g function. So that means I need to go from here to my g function, which is 0, okay? I know to go to the g function because the g function is labeled right here, all right? So when I went here, I had to go look at the g function, and I got a 0. G of 1 is 0. So I'm going to put equals, put my f, open parentheses, the answer to the pink is 0. Close parentheses. Now I have to do it again. But notice again, my 0 became an x again. All right? So go to the x, go to the 0. So I'm right here, but this time they're telling me to go where? To the f function. So I need to go right here. And my f function is equal to 5. So equals to 5. And you're done. Let's try it again. I'm going to do A, B, and C, and you're going to do D, E, and F. F in composition of G of 2, so I'm going to rewrite it. Okay. First, we start with G of 2. So let's go do that. We start with 2 because 2 is our x, and go to our g function. So I look at my x column, and I'm going to start at 2, and I need to go to the g function. So there's my g function, and that is the number -3. So replace the yellow with -3. My -3 became the new x. So I start over at x, go to the -3, and this time I need to go to f. And the answer is 11. So I put 11. Let's go look at C. C is G in composition of f of 2. So G in composition of f of 2 is the same thing as G of f of 2. So what do we do here? We focus on f of 2. F of 2. So start with 2 at x, and I go to the f. My f is a 1. So bring over the g, because I haven't done anything with it, and put a 1 for my f of 2. Do it again. My 1 is an x. So I start at my x. See how you always start at x, right? And I go to the g function. The g function is 0. So my answer is a 0. Okay? All right. Now you need a -1. So I'm going to come over here and write g of -1. And then I need to look at making -1 an x again. But this time this -1 tells us to go to the g, which in this case is a 0. So this answer would be a 0. So check along. You would have done these already. All right, now we do g of 1. So we go to the 1, 1's an x, and it tells us to go find the g, which is the y value at g. So the answer is a 0. So the answer, whoops, is a 0. And they're telling us, okay, now the 0 has become an x again. So I go to the 0, and they're telling me to go back again to the g function. And the answer is a 1. So it's a 1. Okay, let's do it again. F of 3. Okay, I'm going to bring over the f, and I'm going to go look for what f of 3 is. So I need to start at 3 and go to the f, which is here is a -1. I'm going to put my answer. And now I need to start at -1 and go to the f, which in this case is a 7. So hopefully those are the answers you got. Okay? So just remember, as soon as you find your x, start there to go find your y, and then the y value of your function becomes an x all over again. You also need to be able to handle tables. Same concept, all right? So we still rewrite it as h of f of 3. But what you do is you start with the 3 and you go to your f function, and you have to read the graph instead of a table, okay? So I'm going to start with 3. Now remember, 3 is an x value, and your x value is always going to be your x-axis. So I'm highlighting that in yellow, all right? So you're starting at 3. Now they're telling you to go to the f function. My f function is blue. You notice that? My f function is blue. So I need you to start at 3. So I'm going to, let's use this. I'm going to start here at 3, and I need to go to my f function. Am I going to go up or down to go to my f function? Well, in this case, I had to go 1, 2, 3, 4 units down to touch my blue graph. Why the blue graph? Because the 3 needed to go to the f function. So that's 1, 2, 3, 4 negative values. So I'm going to change, keep the h, and tell myself that I went down 4. Now I start over again. It says to start at -4. So I'm going to start here at -4. And now it's telling me to go to the h function. Well, my h function is red. So 1, 2, 3, 4, 5 units to touch my red. So I'm going to come over here and put 5. Okay? So I want you to do it now for the next 4. Pause the video and try it out. Okay, let's do this. So f of g of 4. So start at 4, starting at 4, and I have to go to the g function. The g function is the green, so 1, 2, I had to go up 2 units. Notice you're either going up or down. That's all you're doing, okay? So I went up 2 units. So f, I went up 2 units. Now I put an equal sign. I start on the yellow again. I'm going to be here on 2 because it's f of 2. I need to go to f. F is my blue graph. I have to go down 1, 2, 3 units to touch the blue graph. So down 3 is -3. F of -4 equals, all right, start at -4. I have to go to F. That means go down 1, 2, 3, 4, 5 units to get to F. So F, go down 5 units. Then I have to start again at -5 and go to F again. 1, 2, 3, 4, 5, 6 units. So down 6 units to get to the F function. G of 1. We will start on the 1. We have to go to the G function. Well, guess what? I'm already touching the G function. I didn't have to move. I just made a dot where I was starting, so I didn't need to move, so I'm going to put a 0. I didn't have to move. And now I have to start at the 0. And I have to go to the G function. Now this time I did have to move 2 units up. 1, 2. So here, G of 0 is a 2. Okay? Oh, I didn't write that out correctly. Let me do that again. Hold on. G of 1 is G of 0, which is a 2. All right, here we go. Let's go into this next one. G of H of 0. So I start at the 0 and I need to go to H. Where is H? H is red, and I have to go 1, 2, 3, 4, 5 units to touch the red graph. So G of 5 equals, start over again, go to 5, and I need to go touch my G graph. Well, my G graph is green and I'm already touching it, so my work there is done. It's a 0. Okay, so please notice that all the values that you're looking for, okay, your movement is up and down. I give you the X, so you start on the yellow, okay, yellow is X, and you go up or down to find the Y values, okay? All right. Last but not least, application of composition of functions. Sometimes you guys are going to get real-world application problems that also include composition. So here's an example, and this is our last example. The number n of bacteria in a refrigerated food is given by n of t equals 20t squared minus 80t plus 500. T is always going to fall between the numbers 2 and 14 as far as number of bacteria, okay? Where T falls between 2 and 14, where T is the temperature of the food in degrees Celsius. My bad. Okay, so N is the number of bacteria, T is the temperature, and the temperature is always going to be between 2 and 14 degrees Celsius. When the food is removed from refrigeration, the temperature of the food is given by T of T, the lowercase t, equals 4T plus 2, where the lowercase t, which is the temperature, when the food is removed, the temperature of the food is given by, the temperature of the food will fall between 0 and 3, where the T is the time in hours, okay? So they want us to compose N of capital T of lowercase t. I wish they had used different letters. So let's rewrite this notation. All right, so N of T of lowercase t. All right, so just like we've been doing, we start with the inside. So we need to take the capital T of t and we need to substitute it. We need to go substitute it into capital N. Okay, so we need to take that T of t, which is this, and we need to go substitute it into the capital N. So wherever I see a variable, I need to go substitute it into that. So what is that going to look like? Well, n of capital T of t is going to equals 20, open parentheses, I'm going to replace that capital T with 4t plus 2, close parentheses, squared, minus 80, open parentheses, 4t plus 2, close parentheses, plus 500. There is your answer. Okay, so this is the number of bacteria in terms of its hours. Okay, in terms of its hours, amount of time passing. So they want to find the time when the bacteria reaches 2,000. So the number of bacteria has to reach 2,000. So it would be 2,000 equals 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. So for this particular problem, I would suggest that we go use Desmos. And let me see if I can pull that up without messing this recording. All right, so let's see here. How can I do this? All right, let's switch screens here for a second. And let's go to Desmos. But we're going to do Desmos. Can we do graphing? Let me write this equation down. This is going to be a little hard. We'll try. You know what? I will talk to you guys with this in class, so I won't waste time. You would basically, because my computer is going to mess up here. I don't know if it's doing it or not. It's not cooperating with me. So on this side, you would type, here you would type the equation, and then you would set it equal to 2,000 right over here. And when you do so, you're going to find the intersection of the points. Let me see if I can do this. Hold on. 20, open parentheses, 4t plus 2. So let's see, 20, open parentheses, I forgot already, 4t plus 2 all squared. All right. 4x plus 2, you see it's going to be 4x plus 2, close parentheses, all squared, and then it's going to be minus 80, all right, minus 80, open parentheses, 4x plus 2, close parentheses, and then we had to do what? Plus 500. Let's see if I can pull this off. All right. And this one here, we had to put y equals 200. Y equals. So if we graph this, which I can tell that it's not really showing up. Okay, it is showing up here, but it's not going to. The t value is going to be 2.22222 is going to be our answer, if I'm not mistaken. I wish I could have a better graph. It's not really showing me, because that's supposed to be a parabola, and it's probably too steep. But yeah, so you're looking for the intersection. There we go. There we go, there we go. This is the beauty of Desmos. All right, so I'm trying my best. So it's supposed to be a U-shaped graph. If I keep playing with it enough. There we go. Look at that. Okay, so where is this graph intersecting? Well, it intersects right here at negative 2.222 and at positive 2.222. So the t-value here, if I can get that to expand again, the time in, what was it, hours, is going to be 2.222, and it's repeating hours. And that, using Desmos, would be how you would find that intersection. You can do it by hand, of course, but it would be a nightmare. And in this particular problem, just setting it up and being able to use a graphing tool, you can easily see the intersection. Okay, so find the intersection, and obviously we use the positive value. Why? Well, just common sense, t-value has to be positive, but notice right here, they gave us a constraint that the t-value had to fall between 0 and 3, and voila, we sure did fall between 0 and 3. Thank you for watching this very long lesson, and hope it helps you with this lesson on composition. Thanks for watching.